Hello, welcome to the Math and Physics channel. Today our lesson is about projectile motion. Projectile motion, it is a two-dimensional motion where gravity is the only force acting on the projectile. In this lesson there is no air resistance. Do you see? Written in parentheses, no air resistance. The path of the projectile is called trajectory, and trajectory, the path of the projectile, and the path is a parabolic path. See here, there is a projectile motion starting from V initial velocity and ending in the V final. Or if you don't know this V, you can write VF to be clear that it is a V final. Anyway, note that the magnitude of the velocity vector decreases in the way up and increases in the way down. Study of motion. Here, as you can see, there is a projectile motion with the positive y-axis and with a positive x-axis. Here there is a projectile motion with Vy means vertical velocity, and those are components, vector components. One going to the east, Vx, and one to the south, Vy. Here Vfy means final velocity at the y-axis, and here there is angle. This angle is theta, or you can represent that as alpha, theta or alpha. Here Vy stands for vertical velocity. Vy decreases in the way up and increases in the way down due to gravity. At the top, Vy equals 0 meters per second, as you can see in the graph here. Vy is equal to 0 meters per second. And the projectile motion, at the top, Vy is always 0 meters per second. Vi is the same as Viy, and Vx is the same as Vix. So Vix is a variable, we don't know it. Now we're going to see the questions. And Viy or Vy is always 0 meters per second. Take it note. Now equations. Vertically, we use kinematics. The kinematics are those formulas, but why did we put here a small y sign, and here y, and here y, and here y, here y? Because here we are talking about the y-axis. So Vy means final velocity at the y-axis is equal to the V initial plus the acceleration. The acceleration, we need to put it y, ay multiplied by the time. Just the time, we don't put small y sign in the time. Now this V final is equal to the initial plus acceleration times time. V final squared is equal to the V initial squared plus 2 multiplied by acceleration multiplied by displacement, or delta y. Why not delta x? Because here we're talking about the y-axis. Delta y is equal to the half times acceleration y times t squared plus the v initial y multiplied by t. We must put v initial y. Why we must put v initial y? Because now we're going to see the questions involving Viy. Now the last formula is not included in the is not included in this lesson, which is delta x, or displacement, equals to the v initial plus v final divided by 2 multiplied by t. Now this formula, it's not included in this lesson, but why I put it here, because to have more ideas, to tell you that this formula, we just use it if we have a graph. Now here also we have a graph, but not this graph. If we have a linear graph, and as you can see, you have a linear graph, but the other graph for this formula, we use it if the question said, the question says find the displacement. Find the displacement, and you have the givens, v initial and the v final, and you have the time. But here we can't use it here, because here there's an angle theta, and here we use trigonometry. There is no direct relation between this formula and the trigonometry, and this formula, as you can see, involving delta x, and there is no VIY and there is no VF. There are VI and VF, but there is no Y sign. Now the horizontally, the question said find the horizontal displacement. We use this formula, delta x equal Vx times t, or you can put here I, Vix, to be clear in solving problems. Now here, a reminder for the trigonometry or trigonometric ratios. The sine is the sine angle or sine theta, or you can, instead of theta, put alpha. Sine theta is the opposite over the hypotenuse. So here, the opposite, this angle, sine of this angle is the opposite. The opposite is Vy, and the hypotenuse, the opposite of the angle is Vy, and the hypotenuse is Vi. Now you can memorize it as like this. So Vx equals Vi times cosine angle, and Vy equals Vi times sine angle. Now I will talk about cosine. So Vy over Vi, this is the hypotenuse and this is the opposite. So cosine theta is the adjacent over the hypotenuse. The adjacent of this angle is Vx, as you can see, Vx over the hypotenuse is Vy. So the answer, this is A and S means answer. So the answer is, for the cosine, Vx equals Vi times cosine theta, and Vy is equal to Vi times sine theta. We did crisscross here, but ignore the opposite of the hypotenuse. This is just a rule. Don't write Vy high P equal Vi OPP times sine. No, this is wrong. Just write Vx equal Vi cosine theta and Vy equals Vi sine theta. For the Vx we use cosine angle, and the Vy we use sine angle. So memorize those formulas. Those are the questions, and we're gonna solve problems for this lesson. Question 1 says, suppose students. Now we're going to solve problems for this lesson. Suppose students launched a ball with a velocity of 45 meters per second at an angle of 20 degrees to the horizontal. Sorry, I didn't put the degrees. 20 degrees to the horizontal. Now, those students launch the ball from initial point to the final point here, VIY, and here finals VY. Launch the ball projected as a parabolic or trajectory, and here stopped. Now the components of VI and horizontal components of VI. There are horizontal components of VI and vertical components of VI. Now here we used trigonometry. Why did we use trigonometry? To find the VIY and the V final Y. Sorry, there is no V final, just VIX and VIY. So VIX equals to VI times cosine angle. This you need to memorize it. We took this from the sine, which is the opposite over the hypotenuse, but just memorize that VIX is VI times cosine angle. So 45 meters per second. The V initial is 45 meters per second with the velocity 45 meters per second, initial velocity. See here, I write VI equals 45 meters per second. Why not VIY? Because now we're gonna solve it. VIY. VIY is different from VI. VIY means initial velocity. VIY is initial velocity at the y-axis. So VI is 45. Cosine, we have the cosine, and the angle is 20. We use cosine just if we have x. VIX we use cosine. But VIY we use sine, because horizontal components. Components means trigonometry. Okay. 45 times cosine 20, the answer is 42.3 meters per second. Apply in the calculator. It will give you this answer. Or if you don't like using calculators, you need to memorize them. Cosine 20 sorry, cosine 20 is 0.94. Round it to be 0.94 times 45 will gives us 42.28. But if you round it here, there's a number that is greater than 5, so we add 1 on the number that is before this 8 and after the decimal 2, so 3, so 42.3 meters per second. For the vertical, we use VIY equals to VI times sine theta. So VI is 45 times sine 20 is 15.4. Also, if you don't like calculators, you need to memorize sine 20. Sine 20 is 0.3 along decimal. Decimal is a number, by the way. Sine 20 times 45. The answer is 15.39, but if you round it to be 15.4, round it is better. 15.4 meters per second. And if you don't like rounding, keep the answer as 15.3 or 15.39. Those are the givens. We didn't start answering questions. The questions are here. Part 1, we have A, B, C, and D. Now before A, we started putting the givens to solve A. Now this is the first question, letter A. Find the horizontal displacement and the vertical displacement of the ball after 2 seconds. Now for the horizontal displacement, we use delta x, and the vertical displacement, we use delta y. So we have the givens of the vertical displacement, delta y. So here I must put y. Here x. Very sorry. Anyway, the givens are the vertical displacement and the horizontal displacement. Yes. And the vertical displacement is delta y, and the horizontal displacement is delta x. We need to find them. And another given is t, that the time is equal to 2 seconds. Here time is 2 seconds, and Vix is 42.3 meters per second. We have found them from this paper. See, and the VIY is 15. Here VIY is 15.4 meters per second. Also, we found it from here. And the AY, which is acceleration at the y-axis due to gravity, is negative 9.8 meters per second squared. Not gravity. The gravity, we put it at 9.8 positive. But acceleration due to gravity, we put it negative 9.8, and here there's a small white sign telling that this is acceleration at the y-axis. Now, this is the horizontal. The questions find the horizontal displacement and the vertical displacement. This is the horizontal. We use horizontal delta x. So we said that here we said that vertically we use this formula, delta x equal Vix times t. So we used it, delta x equal Vix times t, and Vix is 42.3 times the times 2. So the answer is 84.6 meters. The unit of delta x is meters. Now for the vertical displacement, we use kinematics. We have the givens, acceleration due to gravity, and we have the givens time, and we have the givens VIY. So we need to find the vertical displacement. So the delta y is equal to half AYT squared plus V initial multiplied by time. So 1/2 times AY, we said that AY is negative 9.8, time 1/2 times negative 9.8 times the time is t, the time is 2, here 2 seconds, squared plus VIY, which is 15.4 multiplied by 2, the times also 2. So the answer is 11.2 meters. Now the second question. The second question says that what is the greatest height the ball will reach? Means the question wants us to find the height or the maximum height. Here there is another projectile motion with the initial velocity and the final velocity is 0 meters per second, because in the projectile motion at the y-axis, at the positive y-axis, the initial velocity is 0 meters per second. And here h max means the maximum height. So the question is find the maximum height. And the height is you can also represent height as delta y. Delta y also is height, or you can simply write h equals the formula. No need to write delta y if you don't like it. Anyway, which formula we use? We have the givens Vy, Vi. So yes, Vy means V final y is 0 meters per second. And we have the givens Voy, that means initial, or you can present Vi as Vo, it doesn't matter, or V0. Anyway, so V0y squared plus 2a y delta y max. This delta y is the maximum height, so Vy is 0 meters per second. So this is Vy, we cross it and we write 0 because it is 0. So 0 equals to 15.4 squared plus 2 times negative 9.8, which is acceleration ay due to gravity, times delta y, or the maximum height. So all about substitution. 0 equals 15.4 squared, applying the calculator, to be 237.2 minus 19.6, which is 2 times negative 9.8, times delta y max, or high max. So we take this positive 19.6 delta y max to the other side, equals to 237.2. We keep it on the same side. So divide both sides by 19.6 here and here, cross them, 19.6, 19.6. So the answer is delta y max is 12 meters, or h max, which is the maximum height, is 12 meters. Now instead of using kinematics, this formula is a kinematic formula. Instead of using kinematics and predict what is the final velocity and the initial, and where's the time and the angle, and use this shortcut formula, which is this shortcut formula. First thing, maximum height above the starting point. So gravity is 9.8 meters per second squared, or the gravity is 10 meters per second squared. You can use this or this, doesn't matter. Or, the word or means you can use this or this. The gravity, not acceleration due to gravity, just gravity. So the h max is equal, when the question says find the maximum height and you don't want to use kinematics, use this. You can use kinematics or you can use this formula as you like. The formula is VI times sine theta or sine angle over 2g, which is 2 times gravity. This all of it squared. You need to know something, that just this VI sine alpha squared, this power 2 is not for 2g, is just for this VI and sine alpha. So now replace. VI is 45, so 45 sine 20, all of it squared over 2 times 9.8. The answer is 12 meters. Apply in the calculator, and see you next time. Bye bye.